Hello, my Chem 11 students. I hope you are doing well. I've been thinking about how to offer some video content for you guys. And what I've come up with here is to do a screen recording of me working through a sample problem. So I will try to do this at least once in a while. Please let me know if you find this helpful or if you have any suggestions with how I can make the video content better, because I'm not very experienced with doing this. Okay, I decided that I'm going to show you a stoichiometry sample problem because this is a really typical one for chemistry 11. So the problem says, consider the reaction below, and you're given the balanced equation. What mass of water can be produced if you use 15.0 grams of ammonia? So first, let's just be really clear on what you're being asked. You are trying to find the mass of water, which is H2O. So you're being asked for the mass of this product, and you are told the mass of ammonia, which is NH3. So you are given the mass of this reactant. Let's write a roadmap to have a plan for how we're going to solve this problem. Okay, so you are given the mass of ammonia to begin with. And I told you before, for these problems, if you have no idea what to do at the beginning, just start by converting your given value to moles. If in doubt, most problems will begin by doing that. So when you're given mass, you can convert to moles of ammonia using its molar mass. We'll determine the molar masses in a moment. Once you've got the moles of ammonia, because you're given the coefficients in the balanced equation, so there's a 4 in front of ammonia and a 6 in front of water. Those are the ratios of how these react. So this is telling you that 4 particles of ammonia will be consumed for every 6 particles of water that are produced, or in other words, 4 moles of ammonia are consumed for every 6 moles of water that are produced. Okay, so we can use that ratio to convert from moles of ammonia to moles of water. And then once you've got moles of water, you can use molar mass to convert to mass of water. Okay, so there's our plan. These are the steps we'll be going through using conversion factors. And we're going to need the molar masses. So let's determine those here. The molar mass of water will be equal to 2 times the molar mass of hydrogen, which is 1.0, and 1 times the molar mass of oxygen, which is 16.0. So that will give you a total mass of 18.0 grams per mole. For ammonia, the molar mass is equal to 1 times the molar mass of nitrogen, which is 14.0 grams per mole, and 3 times the molar mass of hydrogen, which is 1.0. So that gives you a total of 17.0 grams per mole. These masses here are just the masses from the periodic table for those particular elements. Okay, now for the solution, actually what I'm going to do is I'll type solution up here so that in the file you've got the problem here and the solution below the line. Okay, so we are ultimately trying to find the mass of water. And so we start with our given value, which is 15.0 grams of ammonia. And we're converting to moles of ammonia. Now, because I'm typing this out, I'm really sorry that I can't show the ratios very clearly, but I'll try to explain it so that it is as clear as possible. Okay, we want grams to cancel out, so I'm going to put 1 mole of ammonia on the top and the molar mass of ammonia on the bottom. So that's the 17.0. Okay, so that will allow grams of ammonia to cancel out, and we will be converting to moles of ammonia. Okay, that takes care of this step here. Okay. Next, we convert to moles of water. So because I want to convert to moles of water, I'm going to write or look back at the balanced equation. There's a 6 in front of water. So I'm going to write here, let me zoom out a little bit. I'm going to write 6 moles of water over 4 moles of ammonia. That's because there's a 4 in front of ammonia here. Okay, so that will allow moles of ammonia to cancel out and will convert to moles of water. So that takes care of now all of these steps. Okay, and then finally we need to convert to mass of water. So I'm going to write the 18.0 grams of water on, on the top, and 1 mole of water on the bottom. Let me just fix the formatting a little bit so that that's all in one line, just so you guys can see it. Just, you know, gotta reduce the spacing a little bit. Okay, there we go, it just fits. Okay, so that will allow moles of water to cancel out, and you will convert to grams of water. All right, so as I said, sorry that these ratios aren't written in a very clear way because it just is tricky and time consuming to do that in a Word document, but hopefully you can follow along with what is going on. And you can, as always, ask me questions by email, and I will get back to you as soon as possible. So mathematically, we're going to, I'll do this in my calculator as I talk through it. We're going to take 15.0 and we're going to divide by 17. Then you're going to multiply by 6 and divide by 4 and multiply by 18. And that's it mathematically. For sig figs, we've got 3 sig figs here, 3 here, 3 here. The other numbers are exact or theoretical rather than measurements, so they don't have to be considered for sig figs. In my calculator, just to write something that's not rounded yet, I get a number kind of like this, and it goes on and on. And so that's the answer from the calculator, but when you round to 3 sig figs, your answer would be 23.8 grams of water. And that is the final answer. So let me put a box around that here. Okay, so there is the overall solution. So this was to determine the molar mass of the substances of interest. This is the overall plan. So I'm just going to highlight all of this. We did all of those steps. And then here's the actual work for converting from mass of ammonia all the way to mass of water. And here is the final answer. Okay, again, please let me know if you find this helpful, and if so, I will try to do that on a regular basis, or let me know if you have any suggestions for making these better. Have a great day. I miss seeing you in the classroom. Take care and stay safe.